Hello everyone, I'm Dr. Arpita Banerjee from Xavier's College, Jaipur. Today we are here in this class of data structure and algorithm. Before seeing the connection of data structure and algorithm, let's first examine what algorithm is. Algorithm along with flowchart is very important to learn any type of data structure. Algorithm is a step-by-step representation of any problem. And when this problem is viewed in form of a diagram or some pictorial representation, it becomes a flowchart. Collectively, both algorithm and flowchart plays the most important role in any programming language. That's why it is advised to the beginners first to design the algorithm of any complex program and then go the coding of the program. Now let's see some characteristics of algorithm which are very important. Finiteness. Every algorithm has to be finite. When I talk of finiteness, it means there should be a starting as well as an ending of your algorithm. Absence of ambiguity. Absence of ambiguity means that the word choices while writing the algorithm should be very clear, very precise. Language independent. Another feature of algorithm is that it is language independent. Whether you are doing writing the program in C language or Java or any other language, algorithm has nothing to do with it. Algorithms are written in pure English language. Input output. When I talk of input output, every algorithm should have an input as well as the algorithm as well as the output for that concerned algorithm. Any algorithm without a valid input or a valid output is of no use. Effectiveness. Last but not the least, the important characteristics of the algorithm is how effective it is to solve a particular problem. Now let's see some of the properties of algorithm. These properties are given by Knuth and they are broadly classified into five properties. They are finiteness, definiteness, input, output, and effectiveness. All the algorithm which are written by the beginners need to fulfill all these properties. Let's see some advantages of algorithm. Advantages here tell us why there is a need of writing an algorithm. First, it is a step-by-step representation. So it makes us very clear. The vision of the problem is very clear while writing the algorithm. Second, since it is independent of any programming language, hence it becomes very easy for a person to write the algorithm. A prior knowledge of any programming language is not needed by the person who is writing the algorithm. Then, every step of an algorithm has its own logical sequences. Now, it is very well said that the algorithm should be written in a sequence and every algorithm should be sequentially connected with one another. Another advantage of algorithm is that it is very easy to understand and no softwares are needed to modify it. All the steps of algorithms can be easily converted into any high-level language. It also identifies a solution process which helps us in making decision. It divides a huge problem into smaller manageable steps to get the solution. The analysis and specification of the process leads to the efficiency of the algorithm. Separation of the steps divides the labor and development expertise. But besides all these advantages, it's come with certain disadvantages also. First and the most important disadvantage is that it consumes a lot of time. Since we don't have any softwares to help us out, so it is written manually, it is debugged manually, and it is compiled manually. Another, it is inability to solve the problems that generate non-computational results. There may be certain problems in which the results are not generated, and hence the algorithm writing is not supported over there. Now, when we are talking of algorithm, the two most important things are your time and space complexity. Any algorithm without doing the analysis of time and space complexity is incomplete. Time and space complexity means how much time a particular algorithm will take to compute a problem, and the space is that how much space the particular program will require to occupy in the computer's memory. Time is always measured in certain notations which are used your own notations. Like you have a big O notations, O log n. These are nothing but the measuring times of your algorithm. If I talk of space, space refers to the amount of memory required by an algorithm in relation to the input size. It quantifies how much additional memory an algorithm uses concerning upon an input. A small example is over here that if an algorithm that creates an array of size n has a space complexity of On, recursive algorithm also have space complexity due to the call stack, where the space required depends on the depth of the recursion. That is for today's class. Thank you.